I'll be back in a minute. Let me bring the water bottle. I'll be back. 1 second. Hello. Sorry, that was loud, my bad. Let me put this link on the, what do you say, Instagram, and I will be back. Mm-hmm. Copy link. Uh, hey. 1 second. Link. Done. Yeah, coming to the live stream. What's the live stream about? The live stream is about uh, classification in logistic regression. I hope I am audible. Look at my thumbnails, dude. Look at my thumbnails. So yeah, let's start with NG. Google, sorry, Google Machine Learning Crash Course. I was at classification, and I was at accuracy. Accuracy was like predicted, right? Predicted classifications. Yeah, sorry, predicted classifications and total classification. So you have TP plus TN by TP plus TF plus TP eh, TPTN, and we don't have TF. What the fuck? TPTN, and we have FPFN. I hope so. Yeah. Okay. After this, true positive rate classified positives is also known as recall. True positive rate is a proportion of actual positives that were classified correctly. This means that how many values the model classified as positive. Let's say there was a spam. Okay, I trained that this type of mail will be spam. So instead of so yeah, and the AI model, so the ML model uh, classified it as an spam correctly. So it means that what the hell am I saying? So the true positive rate calculates that, you know, it was supposed to be positive, and the ML model also classified it as positive. Then we put it in correctly classified actual positives, and we count how many the AI model was able to classify, and we divide by actual values. Then we get total true first true positives by true positives plus false negatives, and false negatives are also uh, positives, right? False alarm. False positive rate is like uh, actually incorrectly classified for actual negatives by all actual negatives. This is FP by FP plus TN. Okay. Next comes precision. Precision is the proportion of all the models. Precision is the proportion of all the models' positive classifications that are actual positives. This is same as PC. Okay. Instead of FNT, sorry, FP. No. FN, which TP plus FN tells us actual how many positives there are. Okay, this is the total of it. And how do we calculate the precision? Precision, uh, it's like marks, giving marks to the model, like how many were classified as actual positives and how many were actually positives. And how do we find how many were actually positive? That is, one is by true positives and another one is by false positives. Hey, everything classified as positives. Oh, okay. Basically, yeah, like percentage. In a spam classification example, precision measures the fractions of emails classified as spam that were actually spam. Okay. A hypothetical perfect model would have zero false positives and therefore a precision of 1. True. In an imbalanced data set where the number of actual positives is very low, say 1 or 2 examples in total, precision is less meaningful and less useful as a matrix. Precision user improves as a small false positive decreases, while recall improves when false negative decreases. Okay, yeah. But since it's in denominator, yeah. Okay. But as seen in the previous section, increasing the classification false positive and increase the number of false negatives, false positives, and as I go from left to right, it decreases the number of false positives, and as I go from right to left, the false positive decreases, false negative decreases. Okay, as a result, precision and recall often show an inverse relationship where improving one of them worsens the other. Okay, what am I supposed to do? How do I calculate accuracy? Accuracy is like how many were correctly performed. Say TP and TN, that is 40 plus 44, which is 84. 84 divided by 47, all of the sum. 47, and I have 55 and 44. 55 and 44 is like 9. 109. 84 by 109. Hey, how is 84 by 109 85 by 109? But it's 77 though. Yeah, that's what I said. Yeah, how is it 85, man? ChatGPT, I'm out of file uploads. Let me go to cloud. And then I say here, shouldn't accuracy be 77 here? Accuracy be 77 here by 84 divided by 109. 40 plus 44 is like that, you know. Hey, it was 99. 84. 84 plus 7. Okay. Okay. No, how do I calculate precision? Precision is like how many were actually classified as positives. No, how many were actual positives and total number of classified as the positives. It's like finding how many more. How do I define this? Is the ratio of classified as true positives, actual positives. It's a ratio of true positives identified by the model divided by total number of positives, that is true positives that were predicted, that was true positive plus false positive. Now true positive is 40, uh, 40 by 47 is 85 again, I guess. Let me calculate. 40 divided by 47 is 85. Okay. Predicted negative. Sorry. Recall. How do I call recall? Recall is true positive rate. How many positives are there? Right. Let's say it was supposed to be a ratio of true positives divided by true positives plus false negatives. Okay. True positives plus false negatives. True positives are 40. Uh, Divided by 48. 40 by 48 is 83. Exactly. Yeah. Now, how do I increase this? If I increase to the right, true positive decreases. Sorry, false positive decreases. True positive stay as it is. Okay. False positive decreases, and I go to the right, sorry, to the left, false negative decreases. Recall, as you can see, recall and precision are inversely related. If I go to left, since false negative decreases, recall also decreases, so recalls increases, and as I go to right, false positive decreases, and also precision also increases. Okay, yeah. So I have to have a proper point where both of this. Okay, 85, 84, 83 is better, I guess. We're at 47 or something. At 48, okay. The metrics you choose to prioritize when evaluating the model and choosing the threshold depends depends upon the cost, benefits, and risk of the specific problem. In this plan classification example, it often makes sense to use precision, I guess. Eh? back. So the move metrics you choose to prioritize when evaluating the model, nabbing all spam emails or precision, trying to ensure that spam labeled emails are in fact spam, or some balance of the two, or some minimum accuracy. Okay, okay. Accuracy used as a ref indicator of the model's training process. Core convergence for balanced data set. For model performance, use only in combination with other metrics. Avoid for imbalanced data set. Consider using another metric. Okay. Oh, okay. See, in case, what's the formula? True positives. It's total, right? True positives plus true negatives by total, yeah. Recall. When used when false negatives are more expensive than false positives. Okay. Yeah. It's very into for positive precisions more expensive than false negatives. 5 TP 60 and 3 FP and 2 FN. Calculate the recall. Recall. How do I calculate the recall? Recall is true positives by false positives. No, true positives by true positives plus FN. So we have true positives, which is 5. 5 divided by 5 plus 3, which is 5 by 8. 5 by 8 is point 6 heads is 48. 8 6 is 48. 5 heads is 40. 6 heads is 48. So we would need 0.625. TP divided by TP plus FN. Oh, sorry, 2FN. My bad. I. Oh, my bad. So it will obviously, if denominator decreases, the value will increase, and this is the answer. Our model outputs 3 TP to calculate the precision. Precision is true positives by true positive plus false positive. So we have true positive. What's true positive? That is 3 divided by 3 plus 2, which is 3 by 5. 3 by 5 would be 0.6. You're building a binary classifier that checks photos of insect traps. Okay. For whether a dangerous invasive species is present. Okay, if the model detects the species, the entomologist on duty is notified. Early detection of this insect is critical to prevent an infestation. A false assumption is easy to handle. We are going with recall because it's very important because we need um, many high true positive rate instead of precision. Even if it gets false, as you can see, we can handle it. What is rock and oak? Rock and oak. The rock curve is a visual representation of model performance across all thresholds. Okay, the long version of the name receiver operating characteristics is a holdover from. It is drawn by calculating the true positive rate. Receiver operating characteristic receiver operating characteristic curve is drawn by calculating the true positive rate and false positive rate at every possible threshold. Then graphing TPR over FPR, a perfect model which at some point has a TPR, true positive rate of 1, and a false positive rate of 0 can be represented by either a point at. Yeah. Mm-hmm. Area under the curve. Area under the curve. Okay, is OC. Rock is receiver operating characteristic curve. Is a visual representation of model performance across all thresholds. Visual representation of model's performance across all the thresholds. Is a holdover from. Oh. All good. The area under the rock curve, arc, represents the probability that the model, if given a randomly chosen positive and negative example, will rank the positive higher than the negative. The perfect model above, containing a square with side lengths of 1, has an area under the curve. What's the area of it? 1. This means there is a 100% probability that a model will correctly rank a randomly chosen positive example higher than a randomly chosen negative example. In other words, looking at the spread of data points below, OG gives the probability that will place a random chosen square to the right of the randomly chosen circle. A spam classifier with OC1 always assigns a random spam mail a higher probability of being spam than a random legitimate mail. The actual classification of each email depends on the threshold that you choose. For a binary classifier, a model that does exactly as well as random guesses or coin flips has log that is diagonal line. Diagonal line is y is equal to 0 to 0. Oh yeah, that is y is equal to mx plus b. The awk is 0.5, representing 50% probability of currently ranking a random positive and negative example. In a spam classifier example, a spam classifier with awk zero point 0.5 assigns a random spam email a higher probability of being spammed than a random legend only half the time. Oh, awk tells us how many times the model um, puts an positive over the negative. Let's say if awk is 100%, okay, and I have a model which classifies if a mail is email, email is spam mail or regular legitimate email, okay. So when I say that uh, so when I say that when you say what? When you say what, man? Yeah, I was discussing the awk. Oh, my bad. I stopped in the middle. My bad. Let me explain. Let's say you have awk. What awk tells us is, let's say I have 100% awk, a value of awk as 100%, and I have a model which classifies mm, a spam emails. If a mail is a spam or a mail is a legitimate email. If awk is 100%, that means that if I receive email, a random spam email next time, there is a 100% probability that the model will classify it as spam email rather than legitimate email. Okay, if it's 50%, it means that only 50% of the times, let's say I received 20 spam emails, 10 times 20 by 2 is 10. 10 times the model will classify it as an spam email, and 10 times it wouldn't. It will classify it as a legitimate email. Understood, right? Basically, keeping positive above the negative. That's what awk idea is. Mm, Let me take my charger. Awk and rock for choosing model and threshold. Awk is a useful measure for comparing the performance of two different models as long as the data set it is roughly balanced. The model with greater area under the curve is generally the better one. The more the area, the generally it's the better one. The points on a rock curve dataset closest to the points on a rock curve closest to represents a range of the best performing thresholds for a given model. Obviously, this is a better model. You choose depends on which metrics is most important to specific use case. If false positives are highly costly, it may make sense to choose a threshold that gives a low false positives, false alarms. If there are more expensive, then I should use false positive rate. Conversely, if false positives are cheap, then I should go with point C, which is true positives. Yeah. If yeah, if getting false positives is if I get false positives, if I am getting a lower, let's say, if I in spam mail classification email, if a spam is falsely, so if a legitimate email is said falsely as a spam email, and I need to, it's very expensive, it's very penalizing if I say that a legitimate email is a spam email, because of which you could lose a job offer, anything. Then, then what you do? You consider the threshold as A, so that this reduces the low false positive, reduces the false positive rate, so that I get less number of false positives and I get higher positive rates. Conversely, if false positives are cheap and false negatives cheap, if false positives are cheap, if you don't want a legitimate email to be classified as an uh, if you don't want an legitimate email to be classified as an spam email, let's say if false positives are cheap, you don't care much if a legitimate email is said to be an spam email and false negative, and an spam email is said to be legitimate email. You don't care. Then you say the point C, because of which you get more true positive rates. If the costs are roughly equivalent, point B may offer the best balance between TPR and FPR. See, if I go to the right side, false positive decreases. So if false positive decreases, recall increases. Let's see. False positive decreases. If false positive decreases, precision increases. My bad. So if false positive, there are less number of false positives. You get more number of uh, true positive rates, and when you get true positive rates, you choose the threshold moves towards the right. Array. Hi Imran Hanif, how do you do? So this was supposed to go at right. Why is it going at left? Let me use uh, chat Claude for this. If I move, uh, what do you say? If I move the threshold to the right, shouldn't the red dot move to the right? Sorry. Fewer samples. Wait a minute. Fewer samples. Oh, if I go to the right, less number of positives get classified. As you can see, TP also gets 0, FP also gets 0. If I go to left, more number of positives come up, and FP is equal to 51. This would increase the rock curve. The dot means threshold. Okay, understood. In practice, rock curves are much less higher than the illustrations given above. In practice, rock curves are much less regular than the illustration given above. Which of the following represent and awk have the best performance? Whichever has the high graph, I guess 0.77 has highest awk because it has a lot of area being covered. Uh, Imagine a situation where it's better to allow some spam to reach the inbox than to send a business critical email to the spam folder. Wait a minute. Some spam, which is true, to reach the inbox. This is false positive. Okay, this is false positive. False positive is cheaper than false negative. Okay, okay, that's what I said. False positive is less important than false positive. Okay, false negative is less important than the false positive. False positive is uh, this is related to false positive rate, and I should choose point A. Exactly. Love me. You choose this when you have false positive rate. This you choose when you have hard 2 TPR, and this you choose when you have balanced cost for both false positives and true positives. Sorry, false negatives. Coming to the prediction bias. Calculating prediction bias is a quick check that can flag issues with the model or training data early on. My live chat is invisible. 1 second. Yeah. It's a quick check that can flag issues with the model or training data early on. Prediction bias is the difference between the mean of a model. What was bias in uh, mx plus b? The bias was like not the slope, it was like y-intercept. Y-intercept was bias in linear regression. Y-intercept is y-intercept. I think so, yes. Yeah. Prediction bias is the difference between the mean of a model's prediction and the mean of a ground truth labels in the data. Between the mean of a model's prediction, okay, and the mean of ground truth labels in data. Okay, this is same as of linear regression's loss function. Here we have log loss, right? And log loss is like what was log loss doing? I had 1 by n. It was telling me the how many. Yeah, true. You would get good that you are understanding the Vench instrumental. Prediction bias is the difference between the mean of a model's prediction and the mean of ground truth labels in data. A model trained on dataset where 5% of the emails are spam, okay, should predict on average that 5% of the emails it classifies are spam, okay. In other words, the mean of the labels in the ground truth dataset is 0.05, and the mean of the model's prediction should also be 0.05. What this means is, let's say I have a data set of 100 examples. In 100 examples, I have 40 of them as the spam emails. So the model is learning from these 100 examples where 40 of them are spam emails and 60 of them are business emails, sorry, legitimate emails. So what the email should do, when I give another 100 examples, it should also have that ratio. The mean should be the same, okay. The mean of 40 by 100 and the mean of the model's prediction, both of them should be equal. In this, if this is the case, the model has zero prediction bias. Of course, the model might still have other problems. If the model instead predicts 50% of the time that the email is spam, then something is wrong with the training dataset, the new dataset the model is applied to, or with the model itself. Any significant difference between two means suggests that the model has some prediction bias. Prediction bias is simply mean of the ground truth and the difference between mean of the ground truth and the mean of the model's predictions. That is the main idea of prediction bias. Why is it used? It is used to reduce the sorry. Why it is caused? It is caused if you have imbalanced data set. Is there an example? Uh, no. Noises in the data, biased sampling for the training set of features provided to the model being insufficient for the task, bugs in model training pipeline, and okay. Coming to multi-class classification. Classification, we were learning binary classification till now. We learned that if one email is spam or another email is legitimate. Now we'll learn when there are multiple classes, let's say A, B, C, D. When could we classify that? Any examples? Yeah, A, B, C, D. If a topic is in A, if a topic is in B, if a topic is in C. If each example can only be assigned to one class, then the classification problem can be handled as a binary classification problem, where one class contains one of the multiple classes and the other class contains all the other classes put together. The cases can be okay. For example, in a three class multi class classification problem, one second, my mom is calling. For example, in a three class multi class classification problem, where you are classifying examples with labels A, B, C, A, B, C, you could turn the problem into two separate binary classification problems. First, you might create a binary classifier that categorizes examples using the labels A plus B and the label C. Then you should create a second binary classifier that are labeled using the label A and the label B. Oh, so you do two steps instead of one steps, like a binary tree. You know, a tree, you have A, then you classify, you have A, B, C, and you classify to A plus B and C. So you perform binary classifier there. You told either the in first binary classifier you told it can either be A plus B or it can either be C. Then on the next step you told in the first step you decided if it was A plus B or C. If it was C, you stop it there. If it was A plus B, you go inside there and you say A. You do another binary classifier between A and B, and you get whether it's A or B. As simple as that. It's multi-step binary classification. An example of multi-class problem is a handwriting classifier that takes an image of handwritten digit and decides which digit is represented. So let's say I have digits from 0 to 9. I classify 0 to 8 at one class and 9 at the another class. If it's at 9, you stop there. If it's 0 to 8, you divide it again to 0 to 7 and 8. If it's 8, you stop there. If it's not, you go deeper in 0 to 7, 0 to 6, 0 to 5, 0 to 4, 0 to 3, 0 to 2, 0 to 1, 0. That's how it works. This was easy. Coming to the programming section. Programming is very uh, complex in machine learning crash course of Google. I'll just take a guidance from Claude and do it. Why is it so zoomed out? How are so many people joining right now? Did the reel went viral or something? No, it's okay. Doesn't have that many views. It's all right. Yeah. Machine learning, in this collab, you will complete the following tasks. Where was that? Eh? I had used one library where I, not a library, a chat where I had like learned linear regression. Anyways, I'll start a new chat and I will do it in that. Hi there. I'll use this. I am learning programming exercise of logistic regressions classification, and can you please classification and can you please write step by step detailed blocks for Google Colabs notebook. This is the description. Let's start with this, I guess. Let me create a new file, new notebook in Drive, and close this. Okay, leave. I should probably zoom this so that you guys can see the uh, it's threading the whole Google Colab, man. I told him to just and the Google Colab is not opening right now. I don't know why. It's just a black screen. Yeah, we are back. I think this much zoom is enough for you guys. It will be visible if I type. Let's put it more. Who cares? The bigger the better. First, we are supposed to install the libraries and import them. We need OpenPy Excel reader. Everybody remember we use Excel reader, which is OpenPy Excel, which is an Excel file for .excel files. So I have installed pip install OpenPy Excel -q. Let me run this. Why is it taking so much time? And Panda is for like converting the data sets into data frames and visualizing those data set, and NumPy is for mathematical operations. Matplotlib is to uh, what do you say, put graphs around it. Now in that I again don't need, I go to import pandas as pd and import numpy as np and divide by, sorry, not divided by, next line, matplotlib and dot pyplot as plt. This much is enough. What did I do? Matplotlib. Okay, we are done with the installation and imports. Oh, I need to put the sklearn for model selection. Let me put it on the another block. From sklearn dot model selection, import what? Logistic? Is it logistic? Train stress split, I guess. It should be train stress split as much, yeah. Then standard scalar is for, I will tell you why standard scalar is used. Let's say I have two values. Like last time I had taxi. One was distance and another was taxi price predictor. Okay, so there were two features. One was distance and another one was time. So time is like a lesser value. It could be singular value, you know, 1 hour, 2 hours or something in the data set, and distance would be like in kilometers. So when I'm training the model, if I don't use standard scalar, distance would dominate automatically and time would be ignored. So that both of them are treated equally, I use standard scalar. Okay. From sklearn dot model, we do it in pre-processing. So pre-processing, import standard, capital S, I guess, standard scalar. Yeah, okay. Then next is linear model. Okay, we are choosing the model in this. From sklearn dot linear model, import logistic regression. What is logistic regression? CV, man. Import. Oh, all this metrics we need to import. Damn, I thought we would calculate it manually. Anyways, from sklearn dot metrics, import accuracy score. Then we need precision, I guess. Precision, no, precision should be there, no. Precision score is there, why are you not showing, man? Precision score. And next is recall score, which is the exact opposite of uh, the precision score. Accuracy score, precision score, recall score. Three of them done. What was next? The next was supposed to be, I'm done with recall, I guess. TPR is there. Confusion matrix is like for fuck, I forgot. Yeah, the TPFP, TPTNT, sorry, TPFP, FNTN. When I increase the threshold to the right, when I increase the threshold, TP and FP decreases. When I decrease the threshold, FN and TN decreases. So this would be confusion matrix. Then what I need? Then I need rock curve, rock aux score, and confusion matrix display. Might be to display. Rock curve, as you all know, what's rock curve? Rock curve is like, fuck, I forgot. What was a rock curve? rock curve. Fuck. Does anybody remember what rock curve was? Rock curve was receiver operating characteristic curve. It was basically plotting TPR on the y-axis and FPR on the x-axis. So we have rock curve and rock ox score. Rock ox score is the when I plot the graph and the area which covers under the line, plotted line, that area is known as OC. OC is area under curve, area under the rock curve. As simple as that. Then I need confusion matrix display. Confusion matrix display. As simple as that. Over. We are done with the imports, and I will print a statement with print imports successful. I hope I'm pronouncing it right. Sorry, I'm spelling it right. Import successful. I don't know. I think it's a spelling mistake. Anyways, load and explore the dataset. Download the RISE dataset from Kaggle and upload it to the collab. We'll use the URL approach here. Okay. Osmanic. Oh, we have a RISE. A RISE. How do you say? Type of rice. We have basmati here. Basmati. 3-4 more types. Ashirwad. Anything like that. Where are you from? I am from Bangalore, Karnataka. So Osmanic and Cameo, and we have 7 features which decide if it's Osmanic and Cameo. Okay, multiple features. We have area, perimeter, major, minor axis length, area of the rice, perimeter of the rice. Okay, major, minor axis length. Okay, eccentricity, convex area extent. I don't know, man. I just said type of I don't know. Types of rice. Let me see. Types of rice in India. ನಾನು ಚೆನ್ನಾಗಿದ್ದೀನಿ ಬ್ರೋ. ನೀವು ಹೇಳಿ, ನೀವು ಹೆಂಗಿದ್ದೀರಾ? Aromatic basmati and joha, sona masuri, ponni kolam, matta gomida. Okay, but here we have 2 examples. One is Osmansic and Cameo. Okay, both of them are a roughly balanced data set. How do we load it? Upload manually. So this is one method I have done with this. Let me zoom this in. From google.collab import files. This one lets you like open your file explorer and upload a data set. Instead of doing that, let's just grab this. Wait, he said that we will be learning with XLX, right? XLSX, right? Why is it using a CSV? So this is the URL. Then what are we supposed to do? We are converting it into a data frame. Okay, this function, this df basically means I'm converting into a data frame. How do I convert it? PD is from pandas, and pandas has a function called read CSV, read underscore CSV, where I put this URL. This will grab the CSV file and convert it into a data frame. Data frame is like an Excel sheet of that what you are seeing. After this, let me check the shape of it. Shape. Then let me check df dot head. I hope I'm using the correct syntax. Df dot shape doesn't have parameters. It just prints, I guess. अबे यार, print. Damn, the URL is wrong. 5 मिनट, 5 मिनट, 5 मिनट. Bro, it gives a 404. From import mean what? From import means, like, you know, in coding we have something called classes and objects. So these libraries are defined as classes. So let's say I have a bigger class and it has small objects and functions which are inside of them act as classes because of they have constructors or something. So how do I call them is from this class import this function. Okay. See, sklearn is a full class. It has so many functions. One is the linear model. Another one is the what was another one? Let me go. Model selection, metrics. These are all like functions. These functions inside the classes. Do. I'm getting a 404 error because the URL might be wrong. Let me just put it here. If I do LR is equal to linear regression, yeah, but LR you get the model, but inside that linear regression function you said you need to put some parameters like training values, test values, what is the, yeah, etc. I'll put it to the cloud, man. Let him do what he says. आगे से नाता. If you just write like uh, LR is equal to linear regression, that would just initialize the model. If you just, yeah, and it wouldn't train automatically. How many ML algorithms do you know? See, from this live streams, I know only two. Before, when I was coding, I know many. I was doing many neural networks projects, vibe coding, but and so it's mandatory to know OOP before doing ML. For sure, you need to know Python, man. You need to know basics of Python. Like put it like 3-4 days for Python. You will be master in it. And if you know like C, C++, any of those, it's easy to jump to Python. So since we failed with the URL, we are directly downloading another repo from UCIML repo. Let me just delete that block and put this there. Okay, first I need to install it. UCIM repo. Oh, fuck. I know, currently learning EDA, finished LR. Yes, sir. You can learn parallelly, man. What is EDA? Am I missing something? Currently learning EDA. I might be missing something. Oh, you're learning for. Oh, my bad. Basically, that pandas everything. Yeah. I remember. You just explore the data set, right? From USML repo input. Okay. Okay. Just succeeded. And from that, I need to grab this ID, which is rice is equal to fetch UCI repo. ID was, what was the ID? 150 545 545 545. And what was the, according to him, yeah, ID was 545. And next you put the features, and why you put the label data frame. About LR is grouping linear regression or logistic regression that are linearly separable. It's like, let's say, uh, let me take an example. When you want like exact output, you choose linear regression. You don't see for for logistic regression. Logistic regression, see linear regression, as you know, uh, you separate between values. You check for the likelihood. Instead of you checking the likelihood, you limit those values to be in a probability, that is 0 and 1. You check the probability. You don't uh, check the actual output of the model. You check the probability 70% spam email. Yeah, classification in the sense I'm telling for general English terms. Okay. Binary classification and multi-class classification is done in logistic regression. In x-axis, I put the x-axis. Oh, what the hell? Oh, why this? Why did this come here? X-axis. X raw. Okay, why are you taking x raw as the variable? Anyways, x raw is equal to fetch USC repo I don't have premium version. I'm using free tab. X targets and data dot targets, right? Oh, I you plot. Sorry. You have features all in the x-axis, and you put targets, right? Okay. Df is equal to xraw dot copy. Combine into one data frame for exploration. Okay. So the next step I am doing is I am copying x raw and y raw together in a data frame, and a y raw I am keeping in a class. Okay. Df is equal to x raw dot copy and df का जो class है, class is like target. Which target is it? Is it like uska manik or khamuska manik? So I am putting the y target, y raw, which is the target, dot copy there. Now let me check the df dot shape. Then I will check the df dot head, like first data. Let me run this. Yeah, BTech in CSC, BTech in CS. I am in my second year. Okay, area, these are all x values. These are all will be plotted in x values, and class is y axis. This will be like x1, x2, x3, x4, x5, x6, x7. And when I provide weight, it will be w1, x1, w2, x2, w3, x3, w4, x4, w5, x5, w6, x6, w7, x7. Okay. Yeah, dude. See you to all the best. Okay. Then we are done with the step 2, I guess. Coming to step 2, I am done. Coming to the oh my god. Exploration data analysis. We are doing exploration data analysis. I think it's gone. We are checking if there are any null values or anything. Df dot data types, I know it's same. Print df dot d types. This would print all the data types. We have areas. Yeah. Then I should check if how many value counts it has. What does value count do? As far as I remember, df class dot value counts Oskamanic 220 cameo 1630. Okay, then I need to check if there are any null values. Printf df dot is null dot sum, I think is the correct syntax. No, printf is from C language, my boy. Why are you using printf and all? There are no uh what do you say, what does any dot any mean? There are no null values. Let me just check up real quick with Gemini. Gemini is here. Hey, I one time copied, man, to see what was that uh, EDA he meant. Why is any two times written? I'll wrap up after this programming exercise. Programming exercise and test your knowledge. Will give a quiz and wrap it up. Probably tonight I would go live if I come home early. Tomorrow for sure I will complete this data. And next week I need to complete both of this advanced ML models and real world ML. And move to projects. Crazy ass projects. Okay, so then the any function is used twice to check for the presence of any missing values in the entire data frame. The first time returns a boolean data frame of the same shape as, where true indicates a missing value and false indicates a non-missing value. When any is called on this boolean, it returns a boolean series. Each element in this series corresponds to a column and its value is true if that columns at least one true. Okay, let me just put it. Oh, if any one value has null, it returns, and this any returns that column, and if inside that it will run again another any, which will tell which has that value. False, none of them. Thank you God. What is DIF described or run to describe the database basically? What? Oh, basically it tells us count, mean, STD, mean, 25%, everything. Okay, 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 okay. Mm-hmm, mm-hmm. Visualize feature distributions. Now I need to draw a plot. I'll do one thing, man. I have to go by 3, so I will probably uh, end it till step 3. Okay, I'll finish this till step 3 and dismiss the class. Then I'll continue in the evening. You have features is equal to area parameter. Okay, I know that. And figure comma axis plt dot subplots. Explain what this does. Anybody who is here, can you please, you know, say something good, give me some feedbacks, anything. Let's keep it interactive, I want to know who and all is watching. There are 5 people's watching right now. So if you guys like just put something, a first impression, or introduce yourself, anything, it would be better. And where are you from, anything like that. These 2 lines of code are used with matplotlib to set up a figure with multiple subplots. plt.subplots from creates a figure and a grid of subplots. Okay, this variable stores the figure object, which is the main container for all the plot elements. This variable receives a numpy array of access object. It is a single subplot within the figure, 2 rows and 4 columns, resulting in the total of 8 subplots. Okay. As soon as I said that, 2 of them left. Okay. Machine learning is so beautiful, man. Okay, you need to learn it. It's so beautiful. What do I have here? I have like 8 subplots. So 2 rows and 8 columns. These are subplots. This is a whole plot and we have subplots in that. Okay. Figure size is 16,6. 16,6. What does that mean? 16,6. This sets in inches to be 16 inches wide and 6 inches tall. Let me just increase it something like 16,16, 16 inches tall. Alright, 16 inches tall. Oh, the wire is, damn, 6 inches was better. Access.valid, and what does this do? When paradise subset creates a grid like 2 4, the access object is usually a 2D numpy array. For instance, would be, this is like matrix. This stores values as a matrix. Okay. Converts the 2D array of access in one, and this makes it okay. That's good. For I comma feet in enumerate features, what does enumerate do? I forgot. Enumerate in Python. What was the use of it? Enumerate is a built-in that lets you through to a list while keeping tab of the index and the value at the same time. True. I can keep a track of both the index and the value. So I get to use like 2 iterators. Like you use for loop, you have for I in array. I can put enumerate before the array and enumerate of array, and I can write for I comma j in enumerate array, where I would be the index and j would be the value. Okay. For CLS comma color in, CLS is class. Okay. For CLS comma color in Osmanic, comma steel blue, cameo coral. Okay. Axis of I dot hist. NG. I'm having difficulty understanding this. Explain this. Oh, hist is like histogram, right? Hist function was used for histogram. Separated by the glass of rice. For I, comma feet in enumerate, this is the outer loop. Okay. Address to the features list, providing both the index and the feature name for each iteration. I will be used to select the correct subplot from the access array, and fit will be used to select the data column and set to the subplot title. Okay. For CLA's comma color in Osmanic steel blue, cameo comma coral. This is the inner rule. For each fit from the outer loop, this loop runs twice. Once for Osmanic with steel blue color and once for cameo with coral color. That I understood. CLS will hold the class name, that is Osmanic or cameo, and the color will hold the steel blue or coral. That also I understood. Then this fuck ass big line I didn't understand. I have 60k views on the latest reel. Damn. This is the core plotting command executed twice for each feet. Executed twice because we are running this loop twice, right? So, okay. Axis I selects the ith subplot. Okay. It will select the current first subplot. Okay. Remember, axis was flattened into an 1D array. Also, I understood. Dot hist calls the histogram function on that specific subplot. Okay. This is Panda selections that filters your data frame. Df class is equal to creates a boolean series where true indicates rows belonging to the current class. Oh, okay. Class is equal to class will make it like if it's Osmanic, it will put the Osmanic column, and features would be like, ooh, okay, then, okay. Oh, bins is equal to 40. What's bins is equal to 40? Specifies that Instagram should use 40 bins to group the data. 40 intervals, okay. Then alpha is equal to 0.6. Set the transparency, okay, color. Label this is equal to class, assigns the class name. Okay. Color is equal to color, set the colors of the okay. After plotting Instagrams for both classes for a given feature, this sets the title of the current subplot to the name of the feature with a font size of 10. This replaces the legend of the this is unnecessary. We'll do it. After this, we'll need to run a for loop for I comma feet in enumerate. Enumerate lets you have both index and values. Enumerate features. Okay. Then I put a double colon. Then I come inside the loop for CLS is for class and color is for color. In shut up, man. Let me do. Why are you typing in gray? I need to create an array flower bracket. Sorry, round bracket. Enumerate. No, not enumerate. What was that? Osmanic spelling. Osmansic, comma, Osmansic, comma. Oh, sorry, I need to put it in colons. Osmansic, comma. Color is steel blue. Steel blue. Okay, this is first. Next comes color. I am specifying because in graph we need to differentiate, right? We can put any color. Osmansic is blue. Then I come with cameo. Cameo spelling is okay. Then comma. Color is should be golden coral. Okay. This is the inner loop. This runs twice every iteration. Then I say x is equal to access I dot hist df is the data frame. In that we need which class? Current class. How do we get the current class? Current class should be equal to the CLS. Okay, and beside it should be feet. I hope I have written in the correct syntax. Okay, yeah, I have written in the correct syntax. Then beans should be 40. Beans should be 40 and alpha should be 0.6. Alpha should be 0.6. Then labels is CLS and let me just copy this, man. Label is CLS and color is color. We know that, right? Huh? No greeting, man. Thank you. Then we are done with the loop. Then we come to the outer loop. Yeah, here we print this. This is to set the title, and we will see what legend does. This is done. Title. Oh, not here. Oh. Okay, yeah. Let me just run this. This is a syntax error, beautiful syntax error. Beans. There was supposed to be beans, man. Beans or what? Beans. Oh. Beans. Wow. Let me just see this. Do 4, 5, 6, 7. Where is the another one? Where is the another one, man? 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. Oh, yeah, 7 features, right? True, true. We have 7 features. There's something is wrong here, right? No artist with labels found. Steel blue. Cameo to cameo. Okay, my bad. Liver and CLS I added, right? I didn't add. Okay. हो जाती कभी कभी गलती इंसान से. इंसान गलती का पुतला है. Yes. Logistic regression needs numerical labels. We encode. Okay, we then split it into values. Okay, we are converting x is already like values, so we store in x values and y as type int values. So Osmanic it will be 1 and cameo it will be 0. Here we are doing the train test split. Test size would be 0.2, which is 20% of the data set, and random state is 42. I forgot was random state was 42. What does random state 42 mean? For random state 42 mean and random state 42 mean and what, man? दुआओं में याद रखना, खताओं में याद रखना, सताओं में याद रखना. What does random state 42 mean and stratify? These terms refers to how you handle your during the splitting process. Yeah, why do we take that? Is used to seed a pseudo and random number generator. Okay. You get the exact same random shuffle or split of the data. Oh, okay. Okay. Oh, I need to split randomly, right? But in 80-20. So every time I run it, we don't need lots of different values in 80% and 20%. Consistent different values. Inside joke. Henji, can they see home South Delhi key is used to maintain the same processes. Anyways, done. Then what do we do? Then we use standard scaler. Standard scaler is My mom is calling, 1 second. What the fuck is going on here? Sanjay is somehow force. Even I don't know, what's happening here. Completely clueless. It just spawned randomly in between, and is like, what the fuck is happening here? And he's gone, I guess. I think he's gone. Sanjay force. I'm opening your channel. I don't think so. Is related to tech. I don't think so. He's from technical background. Anyways, I'm a YouTuber too, and I have 30 years up. But education content never give you what you want. I never asked for views, man. I'm just studying. What's the big deal? Scalar is equal to standard scalar. Performing features scaling, specifically standardization. Okay, using standard scalar from the. Okay, I know that. This line initializes a standard scalar object. This standard scalar works by transforming features to have a mean of 0 and a standard deviation of 1. I know that. I remember. It should have a mean of 0. I had studied in mathematics probably in my third sim. Okay. This is a common prerequisite for many machine learning algorithms because they perform better when numerical inputs are scaled to a standard range. Okay. Explain is equal to scalar dot fit transform. There's two things in one step. Fit extrain. The fit method calculates the mean and standard deviation for each feature in your extrain dataset. It learns these parameters from the training data. Transform the method that uses the learned mean and standard deviation to scale each feature in extrain. Test data we should not provide. If you provide test data, the model will see the test data. I know that. I remove from linear regression. See, it's crucial to fit the scalar only on the training data. That prevents the data leakage, where information from the test set could inadvertently influence the scaling parameters. The model will sneak a peek into the, what do you say, uh, into your test data. So when you are actually testing, you will get good results because it learned in trained data. Let me just copy this whole. I'll end it here, man, today. gotta go. So 111 minutes ago is almost like 2 hours. A stream of almost 2 hours. What? Class. Is it CL small c? I guess small c. Yeah, small c. It should be fine now. Yeah. Train size is 3048. And we have 62 hours of testing data. We'll train the model in the next step. You have to like train it. Next, we need to plot and ROS and awk sweep thresholds. Changing the threshold shifts called how cautious the model is. Lowering it increases recall. Why does lowering it increase recall? Because if we lower the threshold left side, the false negative decreases. When false negative decreases, since it's in denominator, recall increases and precision decreases. Yeah. For this, I guess we prioritize precision more than recall. Yeah, I'll learn it in the next stream. Uh, Probably today itself, I guess. I'll stream in the evening. See you guys then. Even if you guys can't join later and see the whole stream. Okay, have fun. All the best to every one of you who's watching. Thanks for the support and may all of you do wonders in your life. Okay, thank you so much and bye bye. Probably, I guess, yeah. Because it's Saturday, day 5, I will do it today. Because uh, I am in my weekend holidays. I will probably do it today if I come home early. I'm going outside. Uh, I'll see. I'll put a story if I'm going live today. Else tomorrow. Okay. Everybody have fun. Thank you guys. It was a great stream. Many of you joined today. Probably the first stream. There's so many people joined. Thank you, thank you. Bye bye. Take care. Thanks, Divyansh, Sudeep, Vaibhav, Divyansh Instrumental, everybody. Thank you so much for joining. Love you guys. Bye bye.